This is Algebra Lesson 3-4, Solving Multi-Step Inequalities. Now, we can solve multi-step inequalities in the same way that we solved one-step inequalities, or pretty much the same way you solved multi-step equations. You use the properties of inequality to transform the original inequality into a series of simpler or more equivalent inequalities. So the rules basically are the same as solving equations. You just have to remember that if you multiply or divide by a negative number, you must reverse that inequality symbol. So if I have negative 3x minus 4 is less than or equal to 14, this is a two-step inequality. I look at that and I say I need to get rid of anything that is added or subtracted to my variable, which in this case happens to be the 4 is subtracted. So I want to get rid of that 4 that is subtracted from that inequality. So I am going to add it to both sides of the inequality. Please show that you are adding it to both sides. Don't just add it to one, because that messes up everything else when you're trying to solve. The 4's cancel out, and I get negative 3x is less than or equal to 18. Now I need to divide by negative 3 to get x by itself. And remember, when you divide or multiply an inequality by a negative number, that inequality symbol must reverse. So 18 divided by negative 3 is negative 6. So I get that x is greater than or equal to negative 6. And of course, now I must graph this. Remember, on your graph, you need to have at least a minimum of 2 points, always telling me where 0 is. So if I put 0 here, and let's say I put negative 6 here, it's greater than or equal to negative 6, which means it's a closed circle, and my graph goes to the right. Number 2 says 5 is greater than 7 minus 2h. So the first thing I need to get rid of is that 7. And remember, the 7 is positive. The negative sign that's after that 7 goes to the 2h, not with the 7. That's a very big problem from some people. They see that negative sign and they want to transfer it to the 7, and it's not with the 7. So we will subtract the 7 here and subtract the 7 on the other side of the inequality. These two 7's cancel out. 5 minus 7 is negative 2 is greater than negative 2h. Now to get h by itself, I'm going to divide by negative 2. And of course, if I divide by a negative number, I must reverse my inequality symbol. Negative 2 divided by negative 2 is positive 1. My inequality symbol switches, and I have h because these two negative 2's cancel out. Now, most of the time, people don't graph particularly well when the variable doesn't come first. So I always suggest to people to rewrite your inequality so the variable comes first when at all possible. So in this particular instance, I'm going to have h is greater than 1. Remember, it was pointing toward the 1. It was open toward the h. So when I rewrite it, it has to be open toward the h and pointing toward the 1. Once you have it in the right form, it's pretty simple to graph, because then it points the same direction your arrow should point in your graph. So if I have 0 here, and let's say 1 is here, it's greater than 1. It doesn't equal 1, so it would be an open circle, indicating that it's not equal to it, and it points to the right, much like the inequality symbol pointed right. Problem number 3 here, we have negative 8 is less than 5n minus 23. Again, this is still a two-step inequality. I'm going to add 23 to both sides of the inequality. So I add it to the right, I add it to the left. Negative 8 plus 23 is going to be positive 15. And that's going to be less than 5n because these two 23's canceled out. Divide by 5. Divide by 5. This time I divided by a positive number, so my inequality symbol does not switch. 15 divided by 5 is 3, is less than n, or if I wanted to rewrite it, n is greater than 3. Notice it's still open toward the n and pointing toward the 3. Graphing this is 0, and this is 3. Greater than 3 means it's an open circle at 3 with a line that goes to the right. A couple more problems. Now these problems get a bit more complicated, because if you look at problem number 4, it's got some distributive property that we got to use in here. So if I look at this, the 3x is fine, but I have a positive 4 that needs to be distributed through this entire parenthesis. So I'm going to have 3x plus 24 minus 4x is less than 2. Now we can simplify. Remember, the inequality symbol is my fence line. It's the dividing line between one side of my equation and the other. So notice that both the 3x and the 4x are on the same side of the inequality. So I'm not going to do the inverse operations, I'm going to just combine them because they're like terms. I have a 3x here and a negative 4x here. That makes negative x plus 24 is less than 2. Now it's just a two-step inequality. I'm going to subtract the 24 from both sides because I need to get rid of anything added or subtracted first. 24's cancel out, giving me negative x is less than negative 22. Well, I don't want to know what negative x is. I need to know what positive x is. So I need to either multiply or divide both sides of the equation by negative 1. I like to divide because it's simple. Negative x divided by negative 1 is positive x. Since we divided by a negative number, I need to reverse my inequality symbol, and negative 22 divided by negative 1 is positive 22. And of course, I will graph this. There's my 0. And way down here, we'll put 22. It's greater than, so it's not equal to, so it's an open circle, and greater than goes to the right. All right, number 5. There's no distribution to do here, but we do have variables on both sides of the inequality. Now, if we look at that dividing line of my fence, the variables are on both sides, so we need to get them to one side or the other. I am going to subtract 3z from the right-hand side to get it over to the left-hand side. And remember, I always cross my z's so they don't look like 2's. So these will cancel out. 8z minus 3z is 5z. Is less than 12. And now I'm going to divide by 5. And z is less than 12 fifths. Now that might be hard to graph unless your graph is divided by fifths. So it probably would be easier if we put this into a mixed number. So if I mix this into a mixed number, 5 goes into 12 twice, and that would be 10. 12 minus 10 is 2, so it's 2 and, excuse me. Oh, wait a second. Hold the truck up. I made a mistake way back up here, so I lost my 6. So let's go way back up here and track back up here. This is why we do math in pencil. Because if you're like me, every once in a while you make a silly mistake, which I did because I lost my 6. And as soon as I started looking at this, I'm like, wait a second, I lost my 6. So I've had 8z minus 3z. Let's go back up to that part. That gives us 5z, and we have the minus 6 is less than 12. There we go. That's much better. Now I have to add 6 to both sides. And you will get 5z is less than 18, because the 6's cancel out. Now divide by 5. I still don't have a whole number. Z is less than 18 fifths, which again, you probably don't want to write as 18 fifths because graphing fifths is not necessarily simple. So let's change this to a mixed number. Z is less than 5 goes into 18 3 times. 3 times 5 is 15. 18 minus 15 is 3. So it's 3 and 3 fifths. So if I was to graph this, I have 0 here. 3 here, and just for perspective, let's just put 4 here. 3 fifths is going to be slightly over a half, so I'm going to put it more toward the 4 and less toward the 3, and it's less than that, so it goes left, and it's definitely an open circle. And if you can't tell if it's an open circle, fix it so you can. So I can barely tell, so I'm going to make this more like an open circle. There we go. Now it looks more like an open circle and less like a closed circle. All right, number 6. Number 6, not only do we have variables on both sides, we also have the distributive property on both sides. As you can clearly see, each problem is getting slightly more complicated, kind of like our equations did back in chapter 2. So if I distribute this 5 throughout this entire parenthesis, 5 times negative 3 is negative 15 plus 5d. is less than or equal to 3 times 3 is 9d, and 3 times negative 2 is negative 6. Make sure you pay attention to your signs. I have no like terms I can combine because I have numbers and variables on both sides, but nothing that can be combined on either side. So I'm going to move all the variables to the left side, and I'm going to move all the numbers to the right side. It's just the way I tend to like to do things. So I'm going to subtract 9d from both sides. And that would give me negative 15 minus 4d is less than or equal to negative 6. Now I need to move the 15 to the other side, so I will add 15 to both sides of my inequality. These get canceled out, and I have negative 4d, don't lose that negative sign, is less than or equal to negative 6 plus 15 is 9. Divide by negative 4. We're dividing by a negative number, so reverse that inequality symbol, and you get d is greater than or equal to negative 9/4, which as a mixed number, d would be greater than or equal to negative 2 and 1/4. Okay, so if I'm going to graph that, I have 0 here, negative 2 here. 2 1/4 is going to be barely past 2, quarter of the way, so make a closed circle, and it's less than, excuse me, greater than, I look at, so it's going to point to the right, so it looks like that. All right, so we have to be able to work with word problems as well. Word problems are really, really quite important to be able to do. So it is good to be able to interpret them and be able to write inequalities, just like you do with equations. You're going to do the same type of thing with word problems. So if we have a word problem, the bank is making a rectangular banner that is 20 feet long with trim around the edges. What are the possible widths of the banner if there is no more than 48 feet of trim? Okay, sometimes it's really, really helpful on problems like this. Draw a picture. Okay, so we have a rectangular banner. Okay, and since I have the ability to draw nice little rectangles here, I'm going to draw a nice little rectangle here. There we go. There's my nice little rectangle. 20 feet long, so I'm going to make my longer sides 20 feet. That doesn't necessarily mean the length is always going to be longer than the width. Sometimes the width is longer than the length. Just because it's called length and width doesn't mean length has to be longer. They say that the lengths are 20 feet long with trim around the edges. What are the possible widths of the banner? Well, let's let x equal my possible widths, because that's what we're asked to find. So that's one of the easiest ways to determine this, is what did they ask us to find, and we can try to use that. So if x is my possible width, that means there's an x here and an x here. If you remember, perimeter is equal to 2 lengths plus 2 widths. 2 lengths plus 2 widths. Okay? So if the perimeter is to be no more than 48 feet, because that's how much trim we have, so we can't have a perimeter of greater than 48 feet, then I know that my 2 lengths, and my lengths are 20 feet, plus my 2 widths, which we don't know what those are, so we'll call those x, and you can, so the multiplication symbol, is no more than, which means it could equal up to that, but it can't be greater than that. So that means it's a less than or equal to symbol. And no more than 48 feet, but it could be 48 feet. So there's my inequality. Now I just need to solve this inequality. So 2 times 20 is 40, plus 2x is less than or equal to 48. Subtract 40 from both sides, and you get 2x is less than or equal to 8. Divide by 2. X is less than or equal to 4. So the width of the banner can be at most 4 feet. So you could either write the width of the banner can be at most 4 feet, or you can say the width of the banner can be 4 feet or less. Okay. So there is my answer in a complete sentence, like always. All right. The next inequality, word problem. You want to fence in a rose garden that is adjacent to a deck. Okay. The length of your deck is 14 feet. You have at most 44 feet of fencing. What are the possible widths of your rose garden? Okay, so let's draw the little picture here. Let's say that I have right here is my deck. This is my deck. I have a rose garden that's adjacent to the deck. Adjacent means next to. Okay, for example, in my particular classroom, my room is adjacent to room number 2. We share a shared wall. Okay, so if I was going to plant a rose garden, let's say I just draw my rose garden kind of like this. If I do it up against the deck, I don't need fencing against the deck. That's an important piece here. Okay, so I don't need fencing where my deck is. And of course, I didn't draw this very well because I'm going to go from the end of my deck from each side. So here, my garden then, I'll just do this in a different color since it'll be easier. There's my deck. Here's my rose garden. Okay. It says the length of my deck is 14 feet, which means this side of my rose garden has got to be 14 feet, doesn't it? The other side, I don't have to fence. That's the deck. If I'm going to put my rose garden up to my deck, I don't need to fence where the deck is. Okay? And so I know I have a total of 44 feet of fencing. It says, what are the possible widths of my rose garden? Again, I'm just going to this time I'm going to let W equal possible widths. Always define your variable. Very important. So this is going to be W here, and this is going to be W here. So now we can't use the perimeter formula because we don't have two lengths. We have a width, a length, and a width. So basically, what we have is a width plus a length, which is 14, plus another width, because we're not using that back part that's against the deck. And it says at most 44 feet of fencing, so we know that has to be less than or equal to 44. So there's our inequality. Now let's combine our like terms. W here and W here. W plus W is 2W. Plus 14 is less than or equal to 44. Subtract 14. 2W is less than or equal to 44 minus 14 is 30. Divide by 2. So W's got to be less than or equal to 15. So right now we know that the width must be 15 feet or less. And this is one of those cases where my picture is not drawn to scale, because if the width is 15, 15 is longer than the length, which I told you can happen sometimes. Okay, so the width must be 15 feet or less, or you could have said at most 15 feet. I kind of like answering each one of these slightly differently so that you can see that there's different ways of saying the exact same thing. Let's look at our last concept here. Now, sometimes solving an inequality gives a statement that is always true, such as 4 is greater than 1. That's always true. In that case, the solutions are all real numbers. However, if the statement is never true, such as 9 is less than 5, which is never ever true, then the inequality has no solution. So let's take a look at a couple of inequalities here, and let's see what they end up coming out. So if I was to solve this inequality, number 9 here, I have 14 minus 6n is less than or equal to 2, parentheses 7 minus 3n. So we have to simplify by distributing first. So I'll just leave my 14 minus 6n is less than or equal to 2 times 7 is 14. 2 times negative 3 is negative 6n. Okay. So if I look at this, I have the exact same thing on both sides of the inequality, don't I? If I was to add 6n here and add 6n to the left-hand side, both of these would cancel out, and I would have 14 is less than or equal to 14. Well, 14 is not less than 14, but it definitely equals 14. So in this particular case, this is going to be always true, because 14 equals 14, always. Right? Because remember, if it's less than or equal to, it needs to be one or the other, and it is definitely one of them. So then this is always true, that the answer to this is going to be all real numbers. And if we needed to graph that, to graph all the real numbers, pretty simple. You have a graph like this. Here's your 0. I'm going to put my 0, I'm going to solid that in, and I'm going to go both directions. That's all real numbers. It covers the entire number line, both directions. Let's look at number 10 here. 4p plus 3 is greater than 9p plus 6 minus 5p. Well, we can do some simplifying here. I have a 9p and a negative 5p, so I need to combine those. So I have 4p plus 3 is greater than 9 minus 5 is 4p, 4p plus 6. So if I subtract 4p from both sides of the equation, this will cancel, I'll have 3 is greater than 6, which is never true. 3 is never greater than 6. So since that's never ever going to be true, this inequality has no solution. And you wouldn't give it a graph at all, you would just say no solution. Because you can't really graph no solution. All right then, our closer question for this particular lesson. How can you be sure you solve an inequality correctly? Think about how we made sure that we solved an equation correctly, and apply the same type of concept, and you should be able to answer this question. So how can you be sure you solve an inequality correctly?